For the last video in Chapter 5, we're going to concentrate on getting input from the keyboard into Python. The usual with Python, it's a pretty simple process and also pretty powerful. So the command is basic. It's just input. That will direct input in from the keyboard. Input accepts a string that will output to the screen so you can prompt the user for what you're looking for. In this first case, we're going to be looking for a letter. And then it takes whatever the user types in and puts it as inputs a function. We'll send it to whatever variable you choose to assign it to, or you can use input in other ways too, as any function. So in this first example, we're going to ask the user for a letter, and then after we do that input, we're going to print out the letter you typed in is. We'll print out what the user typed in, just to show that it actually goes into the variable x. And we're also going to print out the type of the variable. That turns out to be an important aspect of getting keyboard input. It turns out it doesn't matter what you type in. Python is always going to treat that as a string. So if you want to use it as something else, then you are going to have to make sure to do some conversion to another format. So let's go through some examples. I've run the program. It's done. This is the input command right here. Type in a letter. So I'll type in an A. I could have typed in something else. Python's not going to check that I typed in a letter. It's just going to take whatever I typed in, convert it to a string, and put it into X. Anything beyond that is up to me to check. So it prints out the letter I typed in as A, and it's a class string. Type in a string. So maybe we'll type in Python. Print out the string you typed in as Python, and its type is still string. Okay, type in an integer. So I'll type in 123. And the integer I typed in is 123, but notice again that the type here is string. When you do the input, Python does not recognize that what you wanted is an integer. Instead, it gives you the string 123. So if we want to do any arithmetic with that integer, we are going to have to do some conversions. So I'm going to type in a float now, 12 1/4. And then this is going to be the last input that we put in. Notice that this input command will sit around and wait forever until I hit the enter button. So right now we are at this command right here waiting to go to the next. As soon as I hit enter, it's going to execute the rest of these commands, and it will do so pretty quickly because, well, it's a computer. So it's going to print out the float, and then I'm going to take the integer and the float and convert them to actual integers. So y will become an integer a, z will become a float b. I'm going to add 12 to a, I'm going to add 12 to b, and then I'm going to print out the two results in one print command. So come down here and hit enter, and there are the results for adding 12 to those two numbers. But again, I want to emphasize the fact that when you take in an input, you have to convert it to the type that you need. So if you want to do arithmetic with any kinds of numbers, you have to convert them to either integers or floats, whatever you think is appropriate. These commands will do error checking. So type in an integer. So I'm going to type in a again. Type in a float. So when I type these in, it's not doing any error checking. It's just saying input something. So I'm inputting a, and Python is perfectly happy to do that. But when I come down here to do the conversion, then Python's going to complain and say you cannot make a into an integer. So I get this invalid literal for int. So it can't convert a into an integer. So that's where the type checking comes in. Okay, this is an example that we did in class. We wrote a factorial function in one of our activities. So quickly review how that works. You call factorial with an integer m. We set factorial equal to 1 to start with. And remember, the factorial is going to be 1 times 2 times 3 times 4 times 5 up to whatever m is. So for all the integers in the range 1 up to m, remember, that range only goes from 1 up to the one less than this number. So in this case, it'll be 1 to m. We're going to multiply factorial times that integer. So this will start off at 1, and we'll do 1 times 1, and 1 times 2, then 1 times 3, and so on up to m. And finally, we're going to print that factorial out. Okay, so down here, the difference between what we did in class and this is we're going to ask the user to input a number, and then we are going to pass that to the factorial function. We're going to input it into the variable number, and then again we have to convert that over to an integer. The only difference between this line and this line is I wanted to note that you can't actually compress this into one line of code without going through the intermediate number variable. Input is a function that returns a string. That string can be passed into integer to convert that into an integer, and that integer then can be passed to the factorial function. Okay, so let's run that to see how it works. So what number do I want to compute the factorial of? How about 5 factorial? So it should be 120. And there it is. So that's the first one. And then, well, I guess we should do it again because I wrote this program to do this again. So we'll ask for 3 factorial, hit enter, we should get 6. Okay, so the point of this exercise again is how does the input command work? Input gives you, as a function, gives you an output, and that output is always a string. Has to be converted into an integer. You're probably getting sick of me saying that, but when you write your key programs, you're going to forget and then say, Dr. Cook, why isn't this working? Okay, a simple compute calculator function. So compute is a procedure. It accepts 3 things. It accepts a number x, a number y, and an operation to perform. The operation can be plus, minus, times, division, and exponentiation, or raising to a power. So we go through a case-by-case analysis looking at the operation. So the first case is the operation is plus, and we just print the sum of the 2 numbers, minus, print the difference, times, print the product. In division, we check to see if the denominator is 0. So this is always a good idea when you're writing a procedure. You really want to assume that the user doesn't know what they're doing and may make mistakes. So this is the kind of error checking that should be done. So we check to see if the denominator is 0. In that case, we could print out undefined, but being mathematicians, we're a funny group, so we print out infinity, which is sort of correct. Otherwise, if the denominator is not 0, we print out the ratio. And finally, if the operation is exponentiation, done what I consider to be the correct way with a hat, we print out the x raised to the power y. And then a last bit of error checking in the off chance that the user types in some kind of weird operation, and we print out a little message saying, hey, I don't know what you're doing here. Okay, so to make this work, down below, we call input to give us the first number, and we convert that to a float, and that goes into first. We ask for the second number, convert to a float, goes to second. And then we ask for the operator, and then we call compute with first, second, and operator. So let's see this thing in operation. Well, I gotta go up here, don't I? And run simple calculator. Okay, so the first number will be a 3, second number will be 4, and we'll add those together, and we get a 7. Notice that the output's always going to be a float because I converted input to float up here. It would be a lot trickier if we wanted to convert based on what the user typed in. If the user typed in an integer and we wanted to convert that to an integer instead of a float, that's a lot more work. And we're not going to get into that. So let's see, we can subtract if we want to. So we are right here running these lines of code. And then when we're done with these inputs, and again, the input's sitting here waiting for me to type something in. When we're done with these inputs, it calls compute, comes up here, execute this, check the F's to see what kind of operation we have to do, print out the appropriate thing, and then we go to the next line, which means you're done. Okay, so what do we want to do? How about we subtract? And 3 minus 4 is -1. There is a little problem with this. So the little problem is that if I type in A here, you get the same thing we did before, which is this value error. It's not a very polite error process. So I'm going to show you something that's a little bit of a bonus. I think it's not something I'm going to require you to do, but it's called exception handling. This is called an exception, and an error has happened. You tried to convert an A, which is what the input was, to a float, and it said no thank you, but it says no thank you in a very obtuse way. So there's a better way to handle that. So come over to Better Simple Calculator. Better Simple Calculator has the exact same compute function. The difference is there is an try except command. And this is a really nice addition, I think, to Python that you don't get necessarily in other languages. So it says try to do these operations, try to do these inputs, and then try to call compute. But if you get an error, and in this case we got a value error, a couldn't be converted to an integer. If you get an value error, then just print out you must type in a number. So it's a little more polite and easier to understand than all this mess that Python was giving us before. So let's run Better Simple Calculator. And if we type in A as our first number, oops, am I running? Oh, I'm still running. I clicked Better Simple Calculator, but then I didn't run it. I was confused for a minute why that wasn't working. Okay, so now we're running Better Simple Calculator. If I type in the first number, this is going to throw an exception. And that exception inside the try, even though we're in the first line, that exception inside the try is going to come back and say, nope, the try didn't work. Go down here to the except and do the print. So it just says you're must type in a number. So let's try it again. Maybe we'll type in a 12 this time. And the second time we'll type in a Q, just being a little obtuse. And again, this throws an exception. That exception is a value error exception. When it throws that exception, the try fails. So it jumps out of this block of code, comes down here to the except and says, oh, for a value error, must type in a number. And otherwise, it works just fine. So if I manage to type in numbers, then it does sort of what you would expect. And just to show, if the user types in a 0 and then tries to divide, then you get the infinity. Okay, so that is the input command. The input command takes a string, which it prints out the screen, waits for the user to type something in, and then puts that into a string. Always, always, always a string. Can't say that enough. No matter what type of variable you think you have,